Hi, good morning, and welcome to this. I would consider it a bit of a special edition to the ZP Developer Zone. It's special in that we've actually just answering limited questions, and they're quite high on regulations. So my apologies, because I know many of you come to listen to this for technical. This is much more regulatory heavy, but I will go forward as well. So at ZP, we do have a fundamental philosophy that we describe ourselves as kind of sensor to API, sensor to application program interface, so we're able to put most biosensor data in the cloud. Now today I'll be talking primarily about glucose biosensor data, though we also, well, we sort of have many applications in mind, from field to cloud and from person to cloud. So all this means that we want to basically put the data into the cloud. We do follow a lot of industrial and biopharmaceutical processes as well. We're very active at the moment in putting glucose sensors into cultured meat and cell culture, and I should suppose stem cell culture at the moment, which is stem cells in particular and cultured meat are kind of interesting and very demanding applications. They're not as straightforward as cell culture, where it's just kind of E. coli. We do have a platform technology that we call Sense It All. This is one of the sort of versions of Sense It All, and this is very sort of one of our most productized platforms, that you can put a sample on this and it'll immediately send the data to the cloud. So if you're interested in kind of being very rapid in terms of testing and making applications, then the Sense It All platform is definitely worth having a consideration. We are having a webinar on this on the 26th of March. This link will take you to the 26th of March, and you can register either for the morning or the afternoon session, just really depending on where you are in the world in terms of time zones. We also do corporate and consulting workshops. If you're a large corporation and you're interested in biosensors and you can bring enough people to that workshop, then this can make for really good let's say value. So we do corporate workshops. We also have workshops at our site as well. This URL is kind of generic, and it'll show you all the workshops that we have organized for 2024. Anyone who comes to a workshop ends up making biosensors and testing biosensors and learning all about biosensors. And as I say, it makes good sense. The corporate workshop, that is, you can have it on site, and it makes sense as long as you've got enough people to attend. The questions I've got today are really around glucose sensing. So one of the questions is, what is the measurement range? And I'll show you some data in a minute. And we typically say sort of 1 millimolar, it sounds ridiculous, to 1000 millimolar. And that's because we're actually going over several applications. It should be said that if somebody asked us, could we do glucose in the micromolar range, then we could, because it's quite a, I don't want to say, it's quite a powerful assay, quite a strong signal, if I could put it that way. Do our sensors support gamma sterilization? Our sensors do support gamma sterilization. When we're on proper programs with clients, we have made up sensors, measure their activity, put them through the gamma sterilization, and then measure them afterwards. It's kind of interesting, actually, because with gamma sterilization, what people intend to do is put the glucose sensor into the application, so it kind of gets embedded or into the form factor, and then it goes into gamma sterilization, because gamma sterilization is sometimes a kind of last step of sterilization. It's important because that question about whether you can withstand gamma sterilization really depends on I think we can do it because we have done it, but then you've got to go into that system. You've got to go through their actual gamma sterilization. So you've got to actually essentially make prototype products that go through gamma sterilization. In fact, we're just doing a program at the moment where we characterize the sensors, they go through the sterilization process, and then they come back to us, so we can sort of ensure that the sensors withstood the sterilization process. So that is, it is something that we've done. You have to do it on a case-by-case basis, especially if you're intending to put that sensor into a larger system, and it's the larger system that goes through the gamma sterilization. You have to treat that as a program in itself. I'll show you some data today that I'm quite confident on the 3 meter length. I mean, 3 meters is quite long. You can appreciate that. We would probably have to actually do it and test it as a small program to answer it, but we have just recently done 0.5 meter length, so confident on it for many reasons. But you'd almost have to try it. Can the sensor be pre-calibrated before shipping? The quick answer is yes. I'll show you how we would do it. Now this is getting into regulatory. So the first regulatory requirement here is this EMA 410/01 part 6.4. And it's really referring to whether we potentially are a source of what they call sort of prions, which can lead to spongiform and Hemolysis diseases. I will describe that in a minute. Biocompatibility, which is fair enough, and I will sort of dig into that. Cytotoxicity, whether we're harmful to maybe the cells in culture. Hemolysis, will we lead to kind of the breakdown of blood? And an important one, endotoxins. It's one thing not to sort of have high bacterial load, but in destroying the bacteria, for example, if you release their internal materials, then those are endotoxic, and especially on things like injectables, it could be quite a problem. So first of all, on the glucose range, it's probably worth saying that at ZP, we make products available on our web store. These are for R&D purposes only. They're really meant to accelerate people's development time, that they can pick up a glucose sensor, they can even pick up a set of electronics, they can test the sensors, see if they like them, and it's a kind of, it's an easy engagement. We also, but the glucose sensors that are on the website are typically sort of developed for human glucose range, which is, humans are not zero, but typically a very 1 to 20 millimolar is what humans are used to. So that is a range that at ZP, one of our ranges that we test for is 1 to 20 millimolar, quite a lot. And we also do work in the food industry. There they actually go up quite a lot. So I should say here that we're testing a glucose sensor here. It sounds ridiculous, it's so high. 300 millimolar to 1 molar. There is not a cell culture bioreactor, I don't think, that would ever run at these kind of concentrations. But that's why it's not easy when people say, well, what's the range of a glucose sensor? Depending on the application, we will tune the sensor to the range that the application is expecting. So if I'm thinking about cell culture, I really think that possibly people go to 50 millimolar of glucose. So this is exceptionally high, but I'm just, when asked the question, what's the ranges we deal with? 1 to 20 is quite typical for us. This one is 300 to 1000 millimolar. It's ridiculously high. And then we may work on ranges where, in this particular application, most of the glucose range they're interested in is more like between 0 and 3 millimolar. We end up tuning the sensor to, depending on the applications of mind. But for most kind of biological applications, they're in the millimolar range, and that's kind of where ZP generally works. Linked to that, once you know what the range is, you can make the sensor according to what range is actually required, and then you may actually have to do some per sensor calibration, which is possible. Now, if you've got a smartphone and you're watching this on, maybe watch this on a screen later on and get your smartphone out, because you'll need to scan some QR codes. So the first thing to say is that ZP, there's an app that you can download. This is the Sense It All app. It's available on the Google Play Store. Scan that code, put the app onto your phone. If you're using iOS, you can scan this app and you can put it on your phone. The reason I do that then is because there's a QR code here that once you've got that app installed, the next thing you could do is scan this code, and this is the glucose. So what this will do is allow your smartphone to work with our Sense It All platform, and actually with that, through that QR code, we are able to transmit individual glucose sensor data. We don't do it by standard, but through that QR code we can. So you can end up having a calibration for each sensor, and we can actually send it out through something like a QR code, so that every offset and sensitivity for each sensor is known, because it's factory set and full factory measured, and then we can transmit it through this QR code. Getting back to the more regulatory requirements, this is I can understand this, that if you make a sensor from materials that come from things like sheep and beef in particular, or cows, I could also see it being a problem with a lot of mammalian sources, you do have to kind of consider the risk of having prion infection. So people unfortunately get this spongiform encephalopathies, which is not very pleasant. It was colloquially called mad cow's disease 30 years ago, possibly, a long time ago. So in order to have a conversation about that really needs us to be, we need to have you in our quality system. So let me say that the products that we put on the website that people can buy for ease of testing out the technology are for R&D purposes only. Once you start into this conversation about prion infection, then we need to onboard you into our quality system. So it's not something that you can just start using. You can start using our products in the manufacture of medical products. You have to really be part of our quality system in order to do that. It's similar for considering our materials that may be involved in otherwise making injectable drugs. In order to answer this question, we really need to actually have you in our quality system. The reason being is there's a distinct line between what's on the website, and then what's on the website is offered as a service, because it allows you to just buy some sensors, buy some test solutions, buy some electronics, get some signals, see if you like the technology. That's much faster to engage with a company doing that than otherwise spending months negotiating contracts and getting materials, and then in the end finding out you're not going to do any business. So it's easy just to buy the stuff and try it out. But if you're going to start using materials in manufacturing materials that otherwise are consequently injected, then you do need to be part of our ISO 13485 system. There is just in vitro toxicity or cytotoxicity. Does this actually damage the for example, if you're doing a bioreactor and it's full of cells, does the material that we're providing cause cytotoxicity to those cells? And again, the answer is it's actually not that straightforward either, because we do a lot of work with simple bacteria cell cultures, and then we do work with stem cell cultures as well. And so the simple answer is it really depends on the material that's being tested. So you actually have to test quite a few ranges these days of cell cultures in order to answer that question. And we would consider that use in R&D is fine, but the use of our sensors, if it's going to be used for making biopharmaceuticals, then the client needs to be part of our quality system on that. Hemolysis, I presume here that if we're making materials that are injected, and injectable materials could lead to hemolysis, then you do have to consider this. And again, we would really require that people who are using our sensors for making materials that potentially could be injected to really be part of our quality system. And it's the same for sterility. I suppose on sterility, I should say that we do have class 7 clean rooms that we keep very clean, and we do test when somebody's part of our quality system. We do test the bioburden in those facilities. So we do test for bioburden and make sure that essentially we're not only clean but we're also sterile as well. So we do have the capability of testing in a quite sterile, manufacturing in a sterile environment. So the simpler questions here really are the technical questions. What is the measurement range? So the measurement range, the question really is, what range are you expecting? Now, I think that most cell cultures, bioreactors are actually running, maybe 5 millimoles very low, but 50 millimolar maybe about the tops that people go. So we would develop the sensor depending on the range that you're actually expecting. We do support gamma radiation. We do have sterilization projects running at the moment where the clients will, we will test the sensors will go through into the client's product, go through sterilization, and then we'll test the sensors again. Because, as I say, when you're doing sterilization, if I put a sensor here, and the sterilization source is here, for example, then I'm essentially in a shadow of the device. So I know these things are rotated within the chambers, but you do have to think about the sensor in the application. You do have to think about the way that you're trying to put this radiation onto this device. But of course, you know, if you behind a certain blocking material, that would effectively cast a shadow. So you do have to do the work. You can't just make a blanket statement. The 3 meters, I think, is quite low risk, but we'd have to do a sort of mini project to test. The sensors can be pre-calibrated before shipping. If you didn't do it, rewind this video, scan the QR code if you're on Android, scan the QR code if you're on iOS or smart or Apple phone, and then scan the glucose. That's how we would get the code out to you. We have recently done some work with longer cables. These were only 50 centimeters, but we did test short cables and long cables. So we had a long cable, a short cable. We had a long cable and a short cable. So we were testing them and just making sure that the signals were the same. So the short one here, short cable is dotted line, then the long cable, then the short cable, then the long cable, then the short cable, the long cable. So we were actually able to. So I'm pretty confident on the 3 meters. 3 meters is quite extreme, but we can do a small project to determine that. So it's okay to take our sensors and to put them into unusual applications and test them on our boards. It's okay to do that, and that's why we put them on this web store. But if you're really intending to actually take these and start using them in medical applications, either diagnostics or producing medical materials, then you really need to be part of our ISO 13485. And I can't make blanket statements about regulations, because then it would sort of encourage a use of our sensors outside of the terms of use. So when you purchase materials from us, we will strictly speaking say for R&D purposes only. If you want a step from R&D purposes only, then we need to onboard you as a client. And we've had this up on the website for this is the third year. So this is a video that, as I say, we've actually had it for quite some time, and it talks about, you know, people being potential clients. At this stage, you know, maybe people are proof of principle, that they've got some sensors, they've got some electronics, so they're really a kind of proof of principle. But if they want to step then into actually considering these products to be used as a medical diagnostic or in the production of medical materials, then they really need to be onboarding as a client, so that we can formally recognize what the requirements are, and then actually make sure that the quality system to produce those sensors is in line with what the client actually needs. Now with these, for example, we've got two routes, which is always complete customization or actually adoption of what we already have. In this case, then, I think we're really talking about ZP instruments which pre-exist, ZP sensors that pre-exist. We also have the cloud for that calibration part that was discussed as well. So we would want to onboard. We've had a client onboarding process for, as I say, the video that I found this morning was put up in 2022. So this is not something new. We've been doing this for quite some time. We would basically come up with the quality system, come up with what's called a framework agreement, come up with the production documentation, which will be against the client's requirements. So, you know, the client has to define their requirements, but that can only be part of a paid program. Then we would actually produce to those requirements. In the first instance, there'd be like a limited availability where the client's basically validated, and then there would be a much larger scale manufacturing process. It should be said that with the form factor that we're talking about in this particular program, then, you know, ZP is capable of producing a few million pieces a month, really no particular issue. So what is the measurement range? The measurement range is orders of magnitude, 1 millimolar to 1 molar, which is basically 3 orders of magnitude, but we would tune the sensor based on what the client actually was expecting. We do support gamma sterilization. We're doing sterilization studies even as we speak. The 3 meter length cable, I'm confident on it, but we'd have to do a sort of mini project in order to test it. Please get your phone out, follow those QR codes. You'll see that we have a way of taking data from our factory out into the field using QR codes. Once you start getting into these regulatory requirements, we need to onboard you as a true ISO 13485 client, we are ISO 13485 ourselves, our requirements require us to onboard you as a client. And then otherwise, if I comment upon some of these requirements, people may buy our products which are intended for R&D purposes on the website and actually start using them in medical products. So I really can't comment upon this apart from, well, what can I say? We actually do biocompatibility studies, it should be said, because we make sensors that get implanted. Cytotoxicity is something that we have experience on, both with bacteria and also stem cells. Hemolysis, that's interesting. It's for basically sort of damaging the blood, and that is something that we could be involved with, but it's risk assessment. You'd have to do a risk assessment on that. I think the risk assessment would say that it's quite low. I suppose a lot of this is actually about a risk assessment, and then endotoxin testing. Yeah, you would have to do that. Of course, when you talk about a sensor, which is quite a small piece in a larger volume, just by dilution, you can sort of reach these endotoxin levels. But you have to be part of our ISO 13485 system. You have to onboard as a client. Otherwise, if I comment upon this too heavily, people will start using our products in the production of medical products, and there's a whole host of concern and risk when people do that. So I say, well, thank you very much. If you've got any questions for ZP, any questions regarding our glucose sensor and their use in the production of biopharmaceuticals, please don't hesitate to reach out to us. Okay, thanks very much.